Hi there, this is Mar Haddad here again. So now we have finished working from the ISP side, the wireless ISP. We have configured everything, and at this time, anyone connected to VLAN 10 or VLAN 20 should have internet, right? So now let's say we have a customer that we want to connect it to the VLAN 10. All right, so now we go to the customer side, we go to his roof, we have lines of sight to our main access point, we put for him a MikroTik access point or MikroTik station, then we connect to it wirelessly, and then we put VLAN 10, and we're gonna see if this router is gonna have internet. So as you can see here, we have 5 points to do. Before I start doing those points, let's go to the lab scenario to show you what we need to do, and I will come back to the points and start doing them. Alright, so just a review, we have now VLAN 10 and VLAN 20. So they are going this way to here, and this is VLAN 10, and we have VLAN 20. All the packets for VLAN 20 also coming to here, and also via the wireless. Let's say that now we are go to the customer, and this customer, which is AP2, I want it to be on VLAN 10. That means you should be able to receive an IP address. What IP address should be? 192.168.0.2. Remember, we made .0.1 on the main router, and we said .2 is going to be provided to the AP2. Now, how can we give this access point or this station internet? We need to enable the wireless on this access point. So the wireless needs to be enabled to be connected to the AP1. And after that, I have to go by a cable to the local area network. So in my case, I'm going to put a cable to my computer to the router. And then we have to see if we have internet. But before we do that, we need on this router, because it has an IP now, we'll be receiving an IP to VLAN 10 interface, we have to create the DHCP server to provide an IP internally to here, the NAT, and the gateway. Alright, so this is what we're going to do in this lab. Let's go now back to the points and start doing that. Point number 1, connect AP2 wirelessly to AP1. So we have AP1, which is the main access point on our ISP roof. We go to the roof of the customer who wants internet from us. We have to put for him an access point, which is for us. Don't give password to your customer for the access point. Don't give him any possibility to configure it. Just this is for you. You make it your configuration only, and you secure it with a password for the administrator. Don't share the password to your customer, because your customer can go to the access point, make any changes, then the internet may stop. All right. So what we need now to do is to go to AP2, and we connect it wirelessly. So we go to, this is AP2. You see, it's called AP2. How to do that? We have to go to the wireless. Remember, we have put on the main access point, we put the password, which is test123456. So we have to do the same here. It should have a password, which is test123456. Now we go to the wireless. Now also I have two, one for 2.4 and one for 5 GHz. This is 2.4, this is 5. Because the main access point is using 2.4, I'm going to use the 2.4. And then let's enable it. Now, how can I connect to it? The step that you need to do first, the security profile, we choose profile 1 because this is the password that we have put. Now, the second thing that you can do is to connect to it. You can put here the frequency and do it manually like we have done in the previous lab, but we have to put here the station bridge. But the easiest way is to go to scan, and you make start scan, and we have to look to the one which is propagating. Remember, the SSID was test. Look, you see it's over here, this one, test. So I make on it, and then I will say connect, and now I will just say apply and okay. So in the moment we have to receive an R, and here we go. R means running. Running means we are now connected to the main access point. And if you want to see, because that's also important for you to see, for example, the RX and TX signal. So because now I'm really very close to the access point to each other, so I have a very good signal. That is the noise floor. Also, signal to noise ratio is very good, and you can see that everything looks fine. And the distance here is 1 kilometer, but yeah, that is the minimum distance. I'm not really 1 kilometer between the two equipment. They are maybe 1 meter far from each other. All right, but now what you see here as bandwidth is not really accurate. You need to make traffic so you can see the exact bandwidth. But so far so good. Everything is now good and I'm connected. But that doesn't mean now that I have internet. So you can just check. If I go to the router to here and I say ping to 8.8.8.8, I don't have yet internet. So we need to do some more steps to have internet over here. Port number 1 is done. Port number 2, now we need to create VLAN 10 interface under WLAN 1 and enable it on it the DHCP client and check what IP it will receive. So what does it mean here? So now we have the wireless phone, right, between the AP1 and AP2. So I will go to the WLAN 1 of this router AP2 and I create VLAN 10 interface. That is VLAN 10. Alright, so I create VLAN 10. That means this one is VLAN 10. This is VLAN 10 here also. Then it can see the VLAN 10 packets. And then I will request on this interface VLAN 10, I will request to receive an IP address from the DHCP server. Which DHCP server? The DHCP server that we have initially created on the main router, if you remember. At the beginning of this course, we created DHCP server on VLAN 10. And in this case, we should have on this VLAN 10 an IP which is 192.168.0.2, because here it was .1, here it will be .2. Alright, so let's see if our all scenario was correctly configured, then we should have this result. And we will do the same when we want to check about VLAN 20. Let's go to the router. Now, I have to go again to the interface here and I will create a VLAN. VLAN 10, the name, and here is VLAN ID 10, and it is under WLAN 1. And I will say OK. So this is the VLAN 10 created, which is under WLAN 1. Let's go to IP DHCP client. Are you ready, guys? Let's see if it will receive an IP address. So we go here and we say VLAN 10, DNS, NTP, and default route, and enter. Let's have a look. And here we go. You see, it has received an IP 192.168.0.2, exactly as I have configured on the main router. Exactly. All right. That means what? That means now this station should have internet. Believe it or not. Look, if I go here and say ping 8.8.8.8, yes, it's able to go to the internet. Ping google.com to check the DNS. It is working. And it is on VLAN 10. So this customer, we put him on VLAN 10. He has internet now on the station. Then all I need now to do, because it has internet, so let's go back here. All I need now to do is just I make here NAT and DHCP server to provide IP to the internal LAN and the route. And that's it. And now this computer will be able to go to the internet. All right, so you get the idea. Port number 2 is done. Port number 3, now we need to check also if we make VLAN 20. So let's imagine that this customer is not going to be connected to VLAN 10, but it's going to be connected to VLAN 20, because also we have VLAN 20 from the main router to check if it's going to work. So we have to create also a VLAN 20 interface on the WLAN 1 and enable the DHCP client. So what I can do, just to not make you lost with this. So let's say that we didn't create the VLAN 10, right? So there is no VLAN 10. I mean, just this is a new customer, which I'm going to put him on VLAN 20. So I will create here VLAN 20. VLAN ID 20, we put it, oops, here it should be 20. We put it under WLAN 1. And then I will say here, okay, now let's think, what IP should this VLAN 20 receive on the DHCP client? Think of it. We gave it for the router 192.168.0.5. Then this one should be 0.6. So let's go to IP DHCP client. And I will say I want to receive the IP to VLAN 20. It should be 0.6. Let's have a look. 192.168.0.6. Yeah, excellent. It's really, really, really nice. So now, let's imagine that you have another customer, you want to put it on VLAN 20. Here we go. He's on VLAN 20. And also, if you check now, if you make ping google.com. It's also able to go to the internet. Excellent. So our configuration is really working perfectly. Port number 3 is done. Port number 4, disable the VLAN 20 and make the configuration so the station is providing internet to the local LAN. So what I want to do now, I want to disable VLAN 20 and I will just enable VLAN 10. Alright, so VLAN 10 is enabled. So let's say that this customer is on VLAN 10. So we see that he has the IP and he's able to go to the internet now on the router. Now what I need to do is to distribute internet to my user to his LAN. So what I'm going to do now, and over here if we go, I'm putting my computer where I'm recording this video, I'm connecting it to the interface Ethernet 5 here. Alright, so I have to do the configuration so my computer can go to the internet. And if you want, I can just show you now that this is my computer. If I make ping 8.8.8.8, we see that we don't have internet server. So I want to connect my computer to the internet, and this computer is connected now to AP2. So we have to do the DHCP, we have to do the NAT, and we have to do the route. So we go to AP2. Now AP2 is able to go to the internet, and here we go. We can try again one more time, and we see that everything is working on the internet. So first of all, what I need to do, I want that all the ports on this router, if I put it on Ethernet 2 or 3 or 4 or 5, it can go to the internet. So what I can do, I can just create a bridge. And inside this bridge, I can put Ethernet 1, Ethernet 2, Ethernet 3, Ethernet 4, and my computer is connected to Ethernet 5. Alright, very good. So that's the bridge. Now I want to, of course, because we put it inside the bridge, we got disconnected. Now I put on this bridge an IP address. We can choose any private IP address. Let's say 10.10.10.1/24, which is on the bridge. Alright, so now we have this bridge, has this IP address. Now we want that all our LAN to receive an IP address from 10.10.10. something. So we can do it on the DHCP server. How to do that? We have to go to IP DHCP server. We create a DHCP server on the bridge. This is the router IP, correct. It gives IP from 10.10.10.2 until 254. That's fine. This is the DNS, and that's fine. Now the last thing that we want to do is to make the NAT. So IP firewall, and we make here NAT. Anything which is source NAT going out of VLAN 10, that is our interface, the out interface, then is masquerade. And that's it. So now, believe it or not, my computer should be able to go to the internet. Port number 4 is done. Port number 5, do you have internet on your PC? Let's have a look. So here we didn't have internet. First, let's see what IP we have received. If we received from 10.10.10. something. So here we go. We received 10.10.10.254. Very good. Let's ping google.com. It is working. Let's do traceroute. So we see how it is going to google.com. So we should see that we are going to 192.168.0. Here we go. 0.1. You see? So it's going to the main router, the internet which is coming from the main router. So it's going to 0.1. Very good. So yeah, it is working perfectly without any problem. Now, if you want to try on VLAN 20, we can also try that. No problem. So let's say that this is the customer. I want him to be on VLAN 20. So we can go from here and we can go to IP DHCP client. We enable first VLAN 20. So let's enable this one. Let's disable this one. So now VLAN 20 has received the IP address. And what I need now to do, the only thing is that I need to do is just to go here to the IP firewall. And then to the NAT, we have to say here, the out interface is VLAN 20. Alright, Now if I go to my computer, if I make ping to google.com is working. If I make traceroute now, we should see that it's going from 192.168.0.5. We should see. Here we go. You see 192.168.0.5. So as you can see, this is really how you can share internet by just doing a wireless ISP. You can see the steps are straightforward. And now if you have a new customer, you create the VLAN on the main router, and then you add it on the switch and on the main access point, and then you create it also on the access point for your customer, and you share for them internet, and that's it. Now, all those steps are the main steps that you need to follow, but we have some issues here. Let's say the wireless. What protocol should we use? What frequency should we use? Are we going to use NV2 or Nstream, or we just use 802.11? All those questions are important questions when you want to deploy the WLAN for your customers, because based on that you can know how much bandwidth you can give to your customers. And also the other thing is that the customer now are getting full bandwidth or not. Because if they are getting full bandwidth, well, I want to make bundles. Like I want to sell 1 megabit, 1 megabit, 2 megabit, 2 megabit. For customers, they pay a different price. So how can I do that? All those questions I'm going to show it to you in the upcoming section, where I have to show you some more features that we can do to make our WISP working better. So this is what I wanted to show you in this lecture. I hope it was informative for you, and I'll see you in the upcoming lecture.